Hey everyone, welcome back to this channel. Today we are going to dive into one of most practically and widely used concepts in risk management, the Monte Carlo simulation for value at risk. If you ever wondered how banks and trading desks estimate the worst cash losses on their portfolios, this is it. And to make it real, we are going to use a simple FX portfolio you consisting of dollar INR and dollar JPY where this portfolio worth is 1 billion US dollar. Okay. We earlier made two videos where we then used historical simulation method, then we used delta normal method. Now today we are going to try Monte Carlo method. Okay. So why were we are using Monte Carlo method? So that is simple. Instead of using returns which are fixed or using historical data, we simulate thousands of possible market scenarios based on statistical properties of past data, like average returns, volatility, and correlations. Then we look at the worst losses across all these simulated outcomes. That's our value at risk. So Monte Carlo simulation helps us capture the distribution of portfolio outcomes rather than just a single number. So all right, let's start with our data. So we have 1 year closing prices of dollar INR and dollar JPY. Okay. In previous video, we calculated the mean of dollar INR, the standard deviation of dollar INR, and the mean of dollar JPY and standard deviation of dollar JPY. Then we also found out the covariance between these two currency pairs. Then we find out the portfolio mean and portfolio standard deviation using this formula. This time we are going to use the Monte Carlo simulation. Okay. So just first I'm going to take a sequence out here. I'm doing simulation. I'm going to create yeah, I'm going to create 10,000 simulations here. Sequence 10,000. Okay. So we go to number 10,000 and we are going to take random values of Z score here. So that it contains all kind of simulations here. So long.inv, we are going to use rand function of Excel. So it has given us random values. So we are going to calculate it for 90, 95% or 99% interval. So we can get sample VAR using this G score, which will be minus portfolio mean plus this G score multiply by portfolio's standard deviation multiply by the value of this portfolio. It will be sample value at risk is going to be dollar 2,534. We can even write this down like this, and we can fix these values here. Just note that these are random VARs, not actual. We can even fix the values of Z4, Z5. After dragging it, we found out this. What I'm going to do, I'm going to trick the Excel into doing all this simulation. So what I'm going to do, I'm just copying this value here. Okay. And now we are going to create similarly this value as well here. You don't need to take these values for these scenarios because these will be similar. I will show you how these will be similar. Okay. So for each click, these are just changing. Now we are going to drag out, and there will be 10,000 simulations. So let's do what if analysis. I'm going to fill a data table. We're going to just select a column input row, and we're going to select any kind of cell, and it will fill our values here. See, so many values here. Even if we want, we can just remove. So if we see every time we are going to change the values are going to change. Okay, and we can find out the 90% VAR in this case. So it will be similar to what we have used in historical simulation. Percentile INC. Going to select these values will be minus this value. So Monte Carlo VAR for this uh, portfolio will be or almost around 90 at 90% confidence it will be $4,376. And if you can see, it is coming negative, and here we are getting a positive VAR. So different. So this is the reason why random G scores can give us random VAR. See it 99% right now. The how simple VAR is so random. And these are giving almost near about values. It will be around 4,400. It is going to be 5,500, and it will be around 7,500. These three. Okay. Even it's not like that we have taken random sample way. The things, all those things will be same. Even if I do 90% here, it will be close to 4,300. Yeah, it is almost close there. Again, we are going to do like 90. Similar values we are going to get. Okay, 95%, 95%, 95%. The range will be similar. 99%. You because data is same. Okay, through this we found out the VAR. We even can just find out the histogram here. We're going to copy it. So if you see, it's similar to a normal distribution. Where is it? We are going to paste it on top. So we got to 90%. We are at 4,383. So it will be approx here. Yes, this is going to be the 90% VR, and 95% we are going to be 5,325. Almost 5325, almost here. And 99% we are going to be 7863, only between these two, right? So it's almost a normal distribution. So through it, this we can calculate Monte Carlo VAR. Very fairly simple process. Normally we just taken 10,000 simulations. Normally people take around 2 lakh market scenarios using Monte Carlo. Okay. So if you find this video useful, give a thumbs up. We are going to apply calculate this using the Python, and in our next video, you can check that out. Okay. Thank you so much. Until next time, keep learning, keep modeling, and stay curious. Thank you so much.